Again, today is going to be really fun. And to kick us off, I'm going to turn it over to our CEO, Jean McCarty.
Thanks so much, Susanna, and thank you all so much for joining us today to experience OutTeach firsthand. We are excited to share some of the amazing work that our OutTeach coaches have been doing during this really unprecedented year in education. And as Susanna mentioned, we have a great session planned today, and hopefully it will also provide you with some fun activities for those days at home during the holiday season. Today's hands-on STEM experience is part of a larger campaign at OutTeach. It's our Education is Open campaign, which is a campaign that's dedicated to addressing critical needs facing our education system now during COVID, but also beyond. We appreciate teachers more than ever right now, and we also celebrate the impact that they have on our students, particularly those at our highest need schools. At OutTeach, we are committed to supporting teachers and to giving them a much needed boost right now as they work really hard to mitigate the learning loss from COVID and as they teach in ever-changing virtual and in-person environments. We launched Education is Open last March, and to date, some of the highlights of our campaign include a Teacher Appreciation Week celebration, a virtual STEM survival camp this summer, the delivery of at-home outdoor learning toolkits, and the remote construction of outdoor learning labs, like the one that we recently built at Harper Archer in partnership with Cox Enterprises. So all of these efforts in our campaign were accomplished with support from corporate partners and corporate volunteers and other community partners, several of whom are here with us today. So I want to thank you for helping us keep education open. It's not too late to join us, though. Our Education is Open campaign will continue into 2021 because we want to continue helping teachers accelerate learning both inside the traditional classroom and also in schoolyards, backyards, and any outdoor space. OutTeach provides this critical support by coaching teachers as they incorporate hands-on learning, outdoor experiences, and real-world applications into the school day. We're committed to a bold vision to ensure that all students, no matter their resources, have access to an education that will transform their lives. This starts, as Susanna mentioned, by engaging students in science and STEM early on. And why this is important is it builds that solid foundation that our students need, but it also sparks their curiosity and their interest in science before it's too late. So to me, that's what it means to open up opportunities for all children. So again, thank you, and especially for joining us during this busy holiday season. And now I will turn it back over to Susanna and our instructional coaches who will invite you to be the student today. Thanks.
Thanks, Jean. So today you are about to take part in a STEM challenge, which is one of the many ways that OutTeach has evolved to support virtual learning. As Jean mentioned, last summer we launched our STEM survival camp where students all around the country took place in a week-long virtual project-based learning challenge. Students were presented with a problem facing our environment and worked collaboratively with their peers and on their own to develop a solution. So you're going to go on a similar journey as an OutTeach student. Our instructional coaches, Ali and Luisa, will lead you through an engineering and design process that is meant to be challenging. It may be hard. You probably are going to feel like you don't have enough information, but that is absolutely the point and how we develop these skills in kids. So trust us, you have the creativity, you'll be collaborating with your peers and other participants to discover answers. So have fun. This process is just beginning in this hour. Pay close attention because following today, you'll have the opportunity to build the STEM project that you're discussing over the weekend with friends, family, and colleagues. This is the holiday season, so we want you to find ways to collaborate and have fun. And maybe the most fun part is that next week, at the end of the week, we'll be choosing a winner of our holiday STEM challenge to win a $100 Amazon gift card. So get ready. And now I'm going to turn it over to our instructional coaches, Ali and Luisa.
All right, thank you so much. I'm so excited to be here with you this afternoon. My name is Ali Graybeal, and I'm the instructional coach for the Carolinas region. When solving problems in STEM, there's a common process that engineers, mathematicians, and other scientists use. And this process is called the engineering and design process, which you see on your screen. The engineering and design process is used in classrooms all over the world to introduce students to STEM. Some of you may be familiar with this process. Some of you may be using it in your classrooms, and for some of you, it may be the first time that you're seeing it. Notice how it starts by asking a question. This question comes from identifying a problem. In the classroom, this problem may be, how can I prevent erosion? How can I prevent the erosion on the playground or in our neighborhood? How can we protect our plants and our crops from high winds or too much rain? Or how can we measure the total precipitation on our campus? After asking what is the problem, they imagine possible solutions. So students will After students ask what is the problem, they imagine possible solutions. Students will brainstorm ideas that may solve the problem. They'll draw on prior knowledge, research, and observations. The next step is to plan. Students will plan and make their imaginations come to life by developing a step-by-step plan that includes labeled diagrams or models and outlines all the materials that they'll need. This is particularly important so that students are prepared to not only build their design, but also for sharing and revising their design as needed. Then, step 4, it's time to create. Students and scientists carry out their plan and build their design. When the design is complete, it's time to test, and they ask, did my design work? Does it solve the problem? How could I make my design even better? Often, the problem is not solved in the first attempt. This is a teachable moment for students as they then would go back to step 3 and revise their plan based on what they learned during their test. Steps 3 through 5 could be revisited several times. Finally, we share. Scientists share their designs and successes with their community. This could be the scientific community and/or their classmates. Everyone learns from collaborating and communicating together, and this is often how the problem is ultimately solved in the best way possible. The engineering and design process commonly takes several days, weeks, even months to carry out in the classroom setting. In the scientific community, it can take years. Today, we'll take you through a quick version as we try to solve our own problem.
Thank you, Ali, and good afternoon or good morning if you are joining from the East Coast. My name is Luisa Aviles, and I am the instructional coach for the Mid-Atlantic region, and welcome to our Holiday STEM event. Today, you're going to be our students, and also you're going to understand how and why we design our learning experiences the way we do it. So do you agree or do you disagree with this claim? What is your evidence? Here is the claim. The same snow that falls today is the snow that fell on George Washington at Valley Forge. During the winter of 1777 to 1778, Washington camped with his troops at Valley Forge, nearly 20 miles north of Philadelphia. So think about this claim. Do you agree or do you disagree? What scientific evidence do you have to support your claim? To bring this back to the way we bring experiential learning to our students, in OutTeach, we use the 5E instructional model. The first step of this model is engage. So during this phase, students are drawn into the science topic and make connections with their prior knowledge. Their interest comes alive and students are curious to learn more. This is the phase where we hook our students into learning the new content and uncover misconceptions students may have about the topic. One way to do this is to pose questions and to show interest in things that begin conversations, while students work together to help each other express this knowledge in few words. Students also begin to identify why they don't understand about the new topic yet. They discuss what they would like to learn and begin to consider what they would need in order to find the answers to the questions. In this case, prior knowledge and understanding of the water cycle and its process is key to succeed in the STEM challenge. So are you ready? Yes is going to share a poll and add your claim to the poll and be prepared to discuss. Okay, so most of you agree with this. Some of you don't agree. So we would like to hear from one person that disagrees with the claim. So if you could please raise your hand and Mackenzie will call your name, or you can also write your answer in the chat box. We would like to hear from you if you disagree with this claim.
Hi, yeah. So the claim, I know about the water cycle. So if it was something where we said like the same water the dinosaurs drank, we're drinking the same water, but for it to be like the exact snow that fell on George Washington is the exact snow that falls today, like we don't get that much snow. Maybe it fell as rain. Maybe it went into the ocean and is currently being, swum in by a fish. So that is why I disagree.
Thank you, Allison.
I think the chance is too small.
Okay. So now we would like to hear from one person that agrees with the claim. If you could please raise your hand and Mackenzie will call your name, or you can also write your answer in the chat box.
I agree, but I am not 100% sure why, but I know it has something to do with the water cycle, that it all comes back together. It goes up and comes back down all throughout all of the years.
Thank you, Katrina. And yes, we are talking about the water cycle here. So basically the water on our Earth today is the same water that has been here for nearly 5 billion years. Only a tiny bit of it has escaped into the space. And as far as we know, new water hasn't formed either. So that means there is a very high chance that the snow or the water that falls today is the same one that fell on George Washington and Valley Forge. And it's also the same water that is going to keep life on our planet in the years to come. Ali?
Thank you, Luisa. So let's begin our trip through the engineering and design process today. The first step in the engineering and design process is to ask, what is the problem? So we've heard from Luisa that we use water every day in all parts of our lives. We drink it, we wash with it, we even use it to flush the toilet. Could you imagine a world without water? What would you drink? What would you cook with? You would have to learn to be creative and resourceful and discover how to find water in some very unexpected places. Now, imagine being stuck at home for the holidays with your family and a pandemic hits. The water is shut off and there's no water to be found in the stores. There would be lots of panic. Would you and your family survive the holidays? So immediately you're probably thinking about ideas, thinking about your outdoor space and reflecting on prior knowledge that you have. And this brings us to the second step in the engineering and design process, imagining. So let's toss it back over to Luisa and get started coming up with new ideas.
Okay, so now that you know what this challenge is about, you have a better idea of why we tap into your prior knowledge of the water cycle. We're now going deeper into the step 2 and 3 of the engineering design process, as is mentioned in the corner of the screen. So after the students research about the topic they are learning, they collaborate and share ideas. During the summer in the STEM camp, we did this in a small breakout rooms, just as you are going to do next. Imagine students for different backgrounds and different areas sharing and collaborating on how they think they can create a device that could find hidden water. The purpose is to bounce ideas off of each other. With the students, we always remind them of using accountable talk and how to share ideas with purpose, whether you agree or disagree with the idea. As you know, collaboration and teamwork, creativity and imagination, critical thinking, and problem solving are learning skills that students need to be able to successfully participate in the global economy and to prepare for college and work. We are going now to imagine different solutions to solve this problem, and we are going to make a plan of what we need. So imagine and plan to create a device that can find and collect hidden water in our everyday surrounding to use for consumption. Mackenzie is typing these guidelines in the chat, so when you go into breakout rooms, you will have them available. You're going to have 10 minutes to discuss as a group where in your environment you can find hidden water, and make a list of everyday materials you could use to create a device. Also, it will be very interesting if you could share what constraints or challenges you think you're going to have. I encourage you to get guidance from the people in your group. And I have good news. An Outreach representative will join you in each of the groups. So we're going to have 10 minutes for this.
All right, it looks like everyone's coming back in. Thank you so much. We had wonderful conversations, and I hope that you were able to kind of collaborate and get some ideas from your peers. So let's go ahead and get back to the screen here. And then we want to hear from you. So would you survive? Please share with us what your group came up with. And so I'll kick us off with my breakout group. Ms. Cooper, can you please share where our breakout group discussed finding hidden water? Feel free to unmute yourself and share.
Sure, the curveball was the hidden water. But we came up with a few solutions. Someone talked about the moisture that they saw on their fences in the morning. Somebody else talked about moisture under plants and also underground wells or sources of water underground.
Thank you so much. Luisa, can you please call on the representative from your group to share what everyday materials your group brainstormed to create the device to collect hidden water?
Yeah, we had a lot of good ideas. So Erin is going to share that. Thank you, Erin, and thank you to my group.
Yeah, absolutely. So we talked about quite a few different things. The main materials we talked about were having some sort of tarp or trash bag, a pail or a bucket, and a funnel, and some sort of fence or protective something that we could surround our device with so no animals could get to it.
Awesome. Thank you so much for sharing. I love that everyone's kind of coming back together and sharing, because some of those things were not mentioned in our breakout group. So hopefully by coming together and all collaborating and sharing, that'll help us kind of move forward with creating our own plans and designs. Wendy, can you please call on your representative to share what constraints or challenges are anticipated when trying to solve this problem?
Oh, constraints or challenges. You know, I didn't ask Diane if she would be willing to share with the group, but she had some great ideas, especially around the temperature changes and the time of year. Are you available, Diane?
Yeah, I'm here.
Hi.
Hi. So we were talking about the time of day and the region that we're in would vary and really kind of drive the amount of moisture in the air if we were to collect through condensation. Then we also talked about tapping into the trees and things for sap like they do with maple syrup. But of course, then that would need to be done in certain regions and at certain times and season changes in the year as well. So some of our constraints really would be, where are we, and what time of year is it? Because some of the things that work here for me in Georgia now may not work for me if it was in the heat of summer or the dead of winter.
Thank you.
Yes, absolutely. Thank you so much for sharing. That conversation sounds similar to one that we also had in our breakout group. So it sounds like where your location, the time of year, the time of day could pose some potential constraints. All right, do we have time to call in a couple more to share, or do we need to move forward?
We have time for at least one more, maybe two.
Okay. Heather, do you want to call on your representative to share what was discussed in your breakout group?
I would love to call my representative. I don't want to alarm anybody, but we have a fantastic idea. Kenneth, will you please share how we are going to survive this?
Yes, I will gladly share. First, I want to give a shout out to Wendy. Hi, Wendy. It's been a while. Good to see you, friend, on here. But yeah, we had a lot of discussion tapping into the hidden water that's in the air and that's in plants. So we specifically targeted taking plants and putting a baggie on the leaves to try to collect water. One of the best ideas that we had was taking grass and plants and muddling them with some soil and the roots included, and cooking them in a pan, in a pot. Because when you cook something, water always evaporates, and with the lid that would be used with the pot, that would collect the water that's evaporating and then condensating on the lid, and then transferring that water over into another device where it could be used for drinking. So that was one of the best ideas that we came up with, was modeling plants, cooking it, and then collecting the water that's evaporating.
Oh, wow, that sounds awesome. It sounds like you were taking kind of all of the ideas that have been shared so far and kind of putting them together, because if that's how hidden water is found, by putting them all together, that may capture a lot of that hidden water. So thanks so much for sharing. I also heard in there a lot of words that are related to the water cycle. So that tells us that we're also tapping into our knowledge of the water cycle. Thank you so much. Katrina, do you want to call on your representative to share what your group discussed?
Sure. After we decided that we were going to all go drive to Shari's house, because she lives near a creek, fish are in there, we will be good to go at Shari's house. But we decided to continue with the discussion. And Vanessa, do you mind sharing what we discussed in our group?
Sure. I'm super impressed by the group right before us who was talking about muddling living things and collecting condensation. We first talked about what water we had around us, and we all have different water. So we had oceans, saltwater pools, creeks, nothing. And so we then kind of dug into the hidden water idea, and we focused on collecting condensation. We didn't really get too far into how to collect, but we also said that we needed to pillage some recycling bins or containers and use those, and also use the natural structures of our buildings for when it precipitates to help funnel water, like a gutter, for example, into these containers. We didn't get to the part about making sure that the water was safe to drink, but we did try to brainstorm different places water was. I think some of the other teams came up with some pretty good ideas too that I want to add to ours.
Okay, thank you so much for sharing. We all had, it sounds like we came up with wonderful ideas, and it just further proves that when you get your students or scientists together in a community to collaborate and share, that's when the best ideas are developed. So moving forward, I want to share with you this design. So thinking how we have already gone through, we have identified the problem, we have planned, we have imagined, and so now it would be time to create. And so this is a creation from a student. And so you see here, they've labeled ocean water, they've labeled lake water. And my question for you that I would like you to either answer by raising your hand and we'll call on you, or by putting it in the chat is, does this solve the problem of finding hidden water? You can share your response by using the raise your hand feature or typing in the chat.
I've got some answers coming in the chat. I hear no, that water is technically not hidden, but the condensation is drinkable. No, hearing lots of no's.
Okay, I see them too. No, not hidden. So absolutely, if water is coming from the ocean or if water is coming from a lake, we would say that that water is not hidden. Just like if water is coming from rain or any type of precipitation falling from the sky, we would say that that water is also not hidden. What this does solve the problem of is filtering water so that it would become drinkable. And I've heard that from a couple of groups, that taking it beyond finding hidden water, you would also have to make sure that that water is drinkable. And that's what this does. You can see that there's a difference between the first image that I showed and this image because of how the modeling is, or how the labeling of the model is done. And it provides us with a little bit more information and insight into what this student was doing. So they filtered out the ocean water, the salt was left behind. Through evaporation, they collected the water through the condensation, and it created filtered drinkable water. They used the plastic bottles to kind of contain it. And then in the lake water, it left behind the sediment, went through evaporation, and then again, condensation, creating that drinkable water. So this does not technically solve the problem of finding hidden water. This is taking water that is already available and making it drinkable. So this is often something that students will find is that maybe their first design or creation doesn't exactly solve the problem. So at this point, we would go back to the drawing board, go back to our original plan, kind of think about what we learned through this process and come up with new ideas or tweak the one that we already had to make it better solve the problem.
Thanks, Ali. So to continue referring to what students learned during the summer camp, in the Outteach STEM camp, here there are 7 pictures of the steps that this student took to design, create, test, and improve her design. So a 10-year-old could do it. You can do it as well. Pay attention to the materials and resources she used. We're going to call this student Luisa. So number 1, Luisa made a diagram of the device she was going to build. One of the materials listed was salt water. Number 2 was her first trial. Number 3, Luisa was able to filter the salt water. But did it solve the problem of fighting hidden water? Did Luisa's design work? No. In picture 4, so with the help of her teacher, Luisa improved her design. How? Building a solar still. The solar still uses the heat of the sun to evaporate water so it can be collected. They are frequently used in areas where drinking water is unavailable, so that clean water is obtained from dirty water or from plants by exposing them to sunlight. A solar still replicates the way nature makes rain. The sun's energy heats the water to the point of evaporation. As the water evaporates, water vapor rises, condensing into water again as it cools down, and then it can be collected. This process leaves behind impurities such as salts and heavy metals. The end result is pure distilled drinking water. Luisa decided to place her device on a tree because she learned that during photosynthesis, plants lose water through a process called transpiration. And a clear plastic bag sealed around the branch allows photosynthesis to continue, but traps the evaporating water. In picture 5, Luisa improved her design again because she realized it was hard to collect the water from the bag on the tree. She combined the first and the second project. Pictures 6 and 7, with more trials, Luisa learned that a more effective way to use this transpiration method was digging a hole and placing clear plastic bags over a leafy branch of a non-poisonous tree and handle the plastic with rocks. So Luisa designed a solar still, but what other ideas do you have? How can you improve her design? Is a solar still the only way to find hidden water? During the summer, we had the students share in many ways, using videos, creating public service announcements, and sharing in a town hall setting. Will you and your family survive the holidays? Ali?
Thank you, Luisa. So now we're entering the last steps of the engineering and design process, sharing. So we've gone through steps 1 through 3 of the engineering and design process today, and now you have the opportunity to go through steps 4, 5, and 6. And our hope is that this will become something you complete with your family. Bring in your children or your grandchildren because you'll need their support. Here is what we need from you. We need a detailed picture of your device, the amount of water you collected, including the units of capacity, so teaspoons, tablespoons, cups, etc., and a brief explanation of how your device solves the problem. Remember to have fun, learn, collaborate, and share. The state of survival is now in your hands. Will you survive?
Thank you, Ali and Luisa. That was so fun. I hope that everyone had fun going through this activity with us. So now I would say the real challenge begins. So this is your opportunity to take part in the Outteach Holiday STEM Challenge. Now I am personally really impressed with all the ideas that came out of the conversation, way more than I would have thought of on my own for sure. So we've all brainstormed ideas to solve the problem of surviving in a pandemic with no water and finding hidden water to survive. So everybody, we've got this really fun, challenging project to create the solution over the weekend. And as Luisa said, 10-year-olds do this very well. So I'm confident that all of us adults can also hopefully rise to the challenge. So as we've said, get together a group, whether it's virtually with friends or colleagues or at home with your family, and create a solution this weekend. So here's the details. In the next few minutes, you'll receive an email with a summary of the project and the instructions, and a jot form that is a link to submit your project when you finish it this weekend. You can take pictures, you can document, you can even submit videos of you putting this together, upload pictures, and then share it with us by the beginning of the week. And so then beginning next week, we'll be highlighting all of these really cool projects that I know everybody's going to build, and you will become our STEM superstars throughout next week, where we'll celebrate your creativity and collaborative time spent with family and friends. So at the end of next week, we'll select a winner from all of the different projects we receive that you upload to receive the $100 Amazon gift card. And we are looking for creativity and ingenuity. And then if anyone has any questions on the project, feel free right now to go ahead and raise your hand or write it in the chat there. And then I also want to say, make sure that you're following us on our social media channels to see everyone's projects. We'll be highlighting our STEM superstars throughout the week next week, as I said. And it's a perfect time to start following us on social media, because we have a lot of exciting new resources for students and teachers in the new year that will be coming out soon after the holidays. It will be free and accessible to everyone. So make sure to stay engaged with us to find out about those as they become available. You can also see here some photos from one of our recent virtual projects with Cox Enterprises, and their employee volunteers spent time at home creating learning features that were installed on a school campus here in Atlanta. And so they did an amazing job of documenting their journey, collaborating with families. And so you can see some examples here of some of those photos that will inspire you to share your journey this weekend. So bring together a group and see if you can become a STEM superstar. So thank you everyone for joining us today. We really do appreciate your engagement and hope that everybody had a fun experience becoming an OutTeach student. We all hope you enjoy your weekends and wish everyone a very happy holiday season, and can't wait to see what everyone comes up with.